Okay, so this is the third example from class, and right now we're looking at finding equivalent concentrated loads, and then also continuing with external reactions, which we've already looked at compound beams previously in the book, but now we're adding that we might have linear loads or constant loads or uniform loads, you could call it that, or functions, loads that are a function, and find reactions. So really quickly, I'm going to start with this is fixed. Okay, just visually I can look at it, it's fixed. And when I have fixed, I'm going to have the possibility of a moment, an X and a Y force that are occurring. If I look over here, I have a roller and it has one direction that it's resisting that translation. So I have 1, 2, 3, I have 4 unknowns. And I have 3 equations of equilibrium, which leaves me 1. If I didn't have this pin, it would be indeterminate. But I do have the pin, and so I can actually take it apart. So I have this internal pin, which takes care of this, so we're at 0. So this is a beam that we can, at this point in time, find reactions for. So the first thing I'm going to do is note any load that is not just a point load. And I know that really when I'm integrating, I'm finding area under the curve. And when I have a nice triangular shape, it's super easy to find that area. Area is 1/2 base times height for a triangle. And so I have 1/2 12 feet times a 1.5 kip per foot. And if I'm watching my units, I know exactly what I need to do because I'm trying to make this a point load. So I'm going to have 6 1.5 times, and I get 9 kips. I'm also going to take note that the orientation of my triangle is in this orientation, and that the centroid the centroid of the section is 1/3 up, 1/3 over, or 2/3 from this direction. So if I am looking at that it is 12 feet, then I've got to be 4 feet and 8 feet for that centroid. So now I'm going to draw a free body diagram overall. And when I do that, I have my unknown AY. So this is my free body diagram overall. And at C, I have the possibility of an X reaction, a Y reaction, and a moment being created because it's fixed. I also can note that I have this internal pin, which right now doesn't matter because we're not taking it apart yet. And I have 3 kips, which is at 4 feet and 4 feet. And then I have this nice triangular load. Again, I like to kind of dot it in just so I have the reference of where it is. And I've got this point load that's acting through the centroid. And if this is 12 feet, again, this has got to be 4, and this has to be 8. So I have all the dimensions, and again, I'm going to note 1, 2, 3, 4 unknowns. I'm going to have to do something with that pin. So this is my overall free body diagram. And now I'm going to have a free body diagram of A, B. Okay, A, B, that's B. So I'll move my camera up a little bit. I'm going to redraw another free body diagram. Should have used my straight edge. I have 9 kips coming down. I have 4 feet, 8 feet, AY, and then I have BX and BY. If I wanted to, I could go ahead and draw this free body diagram over here, and I would have equal and opposite. 3 kips, 4 feet, 4 feet, and then CY, CX, and a moment at C. So I have 2 free body diagrams to work with here, and this one has 1, 2, 3, 4. That's too many. 1, 2, 3, 4, 5. Way too many. I'm going to start right here. So we're going to start with, let's sum the moments about B equals 0. So again, if I have my clock handle at B, A is pushing up, negative moment, 9 kips is pushing down, positive moment. So I've got negative AY times 12 feet plus 9 kips times 4 feet equals 0. And I can quickly find that 9 enter 4 times, 12 divided by, AY is 3 kips. I got a positive value, so it is indeed up in the direction that I assumed. And for many of you that have started to pick this up, you can see that there's, if it's a simply supported beam like this, there is this relationship going on where if I have 9 kips and I have basically a 1 to 2 ratio, then my load is going to be distributed in a 2 to 1 ratio. If I have 3 kips, 9, this is going to be 6, and I can start seeing those ratios to check my work. Okay, so I'm going to go ahead and I don't want to deal with a giant free body. I'm going to work with this one, so I've got to move things through. So now let's sum forces in the x direction, and I find that bx equals 0. There's nothing else on here to balance out an x. And I can sum forces in the y direction. So I get AY, which is 3 kips, minus 9 kips, plus BY equals 0. So BY equals negative 6. Nope. Getting ahead of myself here, aren't I? If I keep BY here, it's positive. Take the negative over, the positive over, so I get positive 6 kips. That means this assumption of going up is correct. That means this assumption of going down is correct. Kips, and this has to be 0. So now we can go to free body diagram BC, and again I try to let you know where I'm pulling my equations from. It's just helpful, especially if you get something wrong and you come in for help. It's easier for us to figure out your work, but I mean honestly it's easier for you to keep up with what you're doing if you can be somewhat organized. So we're going to look at free body diagram BC. So the first thing I'm going to do is sum forces in the x direction, and I have a 0 over here plus CX equals 0, CX equals 0. And I can do a quick scan of my overall, and that makes sense. I don't have anything in the x direction. Okay. Now I can sum my forces in the y direction, and I have BY is going down, so I have a negative 6 kips minus 3 kips plus CY equals 0. CY equals 9 kips going up. Okay, 9 kips going up. And then I can sum the moments. It doesn't matter. I can sum them at B. I can sum them at C. We'll do it both ways just to check our work. So let's sum the moments about B. And if I have a clock handle, remember I'm pushing down. Okay, so that's going to be a negative. CY is going up, positive. MC, I assumed it this way, so negative. CX doesn't matter. Minus 3 kips times 4 feet plus 9 kips, this is CY, times 8 feet minus the moment at C. Okay, I don't have to multiply it by a distance. The moment is already in units of a force distance. We need that. We don't multiply the unit or the moment. Okay, that equals 0. So if I take my moment over so that it's now the positive value, and I've got negative 3, 4 times, 9 enter 8 times, plus I get that my moment at C is 60 kip feet. It's in the direction I assumed because I get that positive value, and I can go back and box it in. If I want, I could sum my moments about C. I could have done that as well. And if I'm summing them at C, it gets rid of C. I have to take into account that it's still there, so I'm going to hold it at B. Oh, I'm going to hold it at C, okay? And BY will push it down. These 3 kips will push it down. CX, CY aren't there, but this MC would want to push it back up. So we have 6 kips times 8 feet plus 3 kips times 4 feet. Okay, I found that this was 60, so I'm going to go ahead and use minus 60 equals 0. 48 plus 12 is 60, so 60 minus 60 equals 0. I did correct work on that little nugget. And I could go back over here and do the same thing. 60 kip feet. CY is 9 kips going up. AY is 3 kips going up. And I could go back to my main free body diagram right here, and I could do a quick 9 plus 3 is 12 coming down. 3 plus 9 is 12 going up. Perfect. Okay, there's nothing in the X direction. And I could sum the moments about any point I wanted to make sure that we were actually in equilibrium.